Okay, this is going to be supposed to be a quick video illustrating how to maintain the current client server model we have in our Electrothon app. Note that the car is the client and the laptop is the server. This may be changed later, but the concept will still be the same. So first I'll just say why this is important. Then I'll go into a demo of how it works kind of in this bare bones structure. Then I'll explain some common bugs. And then lastly, I think I'll show you how this server will be expanded on later and how you can add certain protocols when you are maintaining this app. So this is important because this allows the client to talk to the server essentially. Say, I think the example I'm going to use throughout this video is the client sending its speed to the server. So the people on the sideline on the laptop can be like, okay, the car's 30 miles an hour. Radio in, say you need to drive faster, you need to drive slower, and then the client will receive that. Perhaps it'll be on a radio system, so that will be separate from this system. But either way, the client will be sending its speed to the server, which is what I'm going to illustrate here. So as for the demo, you need to run the server first and then the client because the client connects to the server. And also in practice, you won't be on the same computer with both of these running. When you're developing it, you should be, but in reality, what's on the left side of your screen right now will be the car. What's on the right side will be the laptop. So let's go ahead, run the server. I can see where I was doing this earlier. Okay, we're listening on this IP, aka the server is awaiting messages or connections from clients. Let's reset the client right quick. Okay, so we're connected. You'll see the server said active connections 1. So a new connection has been established and we have a communication line between the two devices. So going back to speeds, say the client sends 30. The server says 30. We got that message of 30 and it's currently just configured to print whatever message it gets. Say it goes up to 34, you got 34, 12, 12, any string of text. That'll be it. Note how you can't do math in here. It's just a string. So let's go over some common bugs, perhaps. I forgot to mention that there is a disconnect message. Exclamation point caps disconnect will just end the connection. So then if you try to send another message, you'll get this error. An established connection was aborted. There's a few reasons why that error will pop up, some of which include the connection not being established due to a disconnection. Others include not having the IPs matched up. Note how the IP of the server is this. If that does not match this, they won't be on the same line. That will also occur if the ports are different. The port is like the ID of the communication line, so that needs to be the same. If you try to send a message and you're getting errors about size, perhaps, make sure that the headers are defined as the same number here, because that is like the size of the message, and if that's different, it might be configured oddly. Also make sure the encoding is the same. UTF-8 is essentially like ASCII, it's like what you see on your keyboard. This is like it allows the server to know what letters, how to interpret the data that's being sent and make it into letters. As you'll see, the disconnect message is exclamation point caps disconnect as we used earlier. In this address tuple, hopefully you know what tuple is if you watched my second video and learned a little bit about Python. You won't really need to change that. And also note that play around with this, experiment, try to make things better, more interesting, or just have fun with it. Note that we're using GitHub, so if you really mess stuff up, just roll it back. Don't be afraid to play with stuff. Don't be afraid to take risks. Just kind of do whatever, have fun, and make it cool. So I don't know if I mentioned that the reason why these are in all caps at the top is because we're trying to make global constants here. As you can see when I hover over it, it's a constant. So that won't be changed throughout the program. You're not going to be changing the IP that's being communicated on. And also you're not going to, or you are going to be able to use these in functions within each program. So let me explain what this handle client function does. This is perhaps the most important function in either of these two. The handle client function is where the server says, okay, we just got a new message from the client. Let's interpret that and perform a response. So if you look at lines 23 and 24, that's where you'll see the instance of this kind of idea occurring currently. If the message equals the disconnect message, as defined in line 9, that's exclamation point caps disconnect. If that is what's sent from the client, make connected false in the connection, cut off the connection between the client and server, however you want to say it. So that's how you will kind of interpret messages. Let's go back to the speed. I'll show you the example of how to kind of elaborate on this server model. Let's do, if the client sends speed and then a number, let's have the server say the car speed is X. So I'm gonna mock that up and then I'll explain. So if we can print speed of the car is, speed of the car should be 6, and we can just say like mph. Okay, so what just occurred? I kind of remodeled this disconnect message conditional statement to see if a message is prefixed with speed. If the first 5 characters in the message sent from the client equal speed, then print the speed of the car is plus the 6th character of the string and onwards, so the last however many characters are after 6, plus miles per hour. So hopefully this works. Let's just do a quick demo. It is very common to forget some of these syntaxes, so this may not work. Let's just see how it goes. So, we started the server, then the client. Okay, we got the IP, they're the same. Send a message like hi. This has nothing to do with speed, so we're not using this kind of protocol at all. It's just printing hi. Now if we say speed 30, the server says the speed of the car is 30 miles per hour. So that's this, what we just wrote in lines 25 and 6. That's this taking action. Note that if we do speed some huge number, it'll do the same. Speed anything, it'll do the same. Even if it's not a number, it'll do the same. So that's an example of how you can use the server model to interpret client messages. Now, this is still relatively basic. Likely what you'll see in future years when the Electrothon app is fully developed, perhaps you'll see the client send speed 30, and then the server takes that, inserts it into the GUI, and then it makes like almost like a speedometer on the screen. It could change the angle of like the arrow in the speedometer perhaps. But any function like that at its basis is using this concept here. So I think that's really all I have for this video. I really wanted to, since we kind of have the model in its almost like a naked state right now, I wanted to go ahead and explain the basics of it so it's not like a ton at once, and also so you guys can see the model's progression as the application develops. So it's not just like a ton at once. You can kind of understand what we were thinking, how we develop the app over time, etc. So yeah, that's all I have for this video. Yeah, make sure these global variables are the same. That'll be the source of a lot of errors, I imagine. And if you want to learn kind of the concepts behind the client server model itself, I'll link the video that I learned this from in the description. If you look at the code in that, this is really a copy paste of that. The code is very similar. But good luck this year in Electrothon, and good luck maintaining the Electrothon program.